Okay, in this question we're going to start off a bit of completing the square. If you want to know how to do this in detail, go back to my answer to question 11 in this series. So I'm going to rewrite the question. So we get x squared plus 2x plus 3. Remember, I always halve this value to get what goes in the bracket, so I get plus 1 lots of this number here, because that's half of 2 squared. Take away this thing squared, so take away 1 squared, and then add on the 3 at the end, and I have completed the square. Just tidy it up. Minus 1 squared plus 3 will just give me plus 2. So therefore A equals 1 and B equals 2. Now I'm going to sketch the graph of y equals x squared plus 2x plus 3. So let's just put some axes in. Well, first of all, I'm going to use this answer here, but I'm going to draw a graph of y equals x squared to help me. So there's a rough sketch of y equals x squared. So this is y equals x squared. Now how have I transformed this to get this? Well, you need to know your transformations. This plus 1 inside the brackets, you add 1 to x inside the bracket, then you translate 1 to the left. Alright? And if you add 2 outside the bracket, you translate up 2. So therefore this is going to shift that graph left 1 and up 2. Good way to remember transformations is they're always the opposite to what you think when they're inside the function. So x squared is a function and you do this plus 1 before you square, so it's inside the function. It's the opposite to what you think. And out, so therefore plus 1 you normally think, well, I'm going to shove it that way. Well, you don't, because inside the function I'm going to move it this way. So let's just illustrate that. So the plus 1 will shift us 1 this way. So we can minus 1 away from every value, and then we're going to shift it up by plus 2. So the new graph will look like this. Alright, and the base of this graph will be at the point minus 1, 2. The easy thing to find out is where it crosses the y-axis. It's always the plus c on the end, which is 3. So we can see where our graph is. And this is our graph y equals x squared plus 2x plus 3 using this transformation process. So let me just highlight that in again. So this was the inside bit that caused this to happen, and this is a bit harder to highlight. And this is the outside bit happening here. So that bit causes a shift up, this bit here causes a shift left. Right. Find the discriminant of this. Now, if you can remember back to question 13, I talked about the discriminant. The discriminant is b squared minus 4ac. You should hopefully be aware that we normally talk about quadratics in the terms ax squared plus bx plus c. If you didn't, you now do. So the discriminant is b squared minus 4ac. The bit that comes under the square root when you try to solve this equals 0. Want a fuller explanation of where this came from? Go back to question 13. B squared, well, that's going to be just 2 squared minus 4 times a in this case is 1, and c in this case is 3. So we get 2 squared is 4, minus 4 times 3 is 12, and that gives us minus 8. Now, remember, if our discriminant is negative, we get 0 solutions. So therefore there'll be no solutions to this problem, and hence our graph doesn't cut the x-axis. So we can see that this relates to graph. Graph doesn't cut the x-axis. Another way to say this is there's no roots. Yep, no roots means it doesn't cut the x-axis, and there's no solutions to ax squared plus bx plus c equals 0. So there's no roots and no values where this will cut the x-axis. Remember the discriminant, this bit here, is less than 0, you get no roots. If it's equal to 0, you get equal roots, i.e. 1 root, and it's bigger than 0, you get 2 roots. Find the possible, now, equation x squared plus kx plus 3 equals 0, where k is a constant, has no real roots. Let's write that out. So we've got x squared plus kx plus 3 equals 0, has no real roots. Well, let's just write out what A is how many lots of x squared is, just 1, B equals k, and C equals 3. We know that has no real roots, and in no real roots, b squared minus 4ac, if you have no real roots, that will be less than 0. So let's put this in. So we get k squared minus 4 times 1 times 3, which is 12, is less than 0. So we have k squared. K is only a constant here. It doesn't have to be positive. So k squared is less than 12. So we know that k is going to be less than root 12. One thing you need to be careful of when looking at these inequalities is what's really going to be going on. If we got k squared is less than 12, if we just look at the x squared graph, there's 12, alright, on our graph, and we want to look at where we're less than 12, then it's going to happen between here and here. And therefore, you're going to get k is going to be less than root 12, and therefore bigger than minus root 12. Is going to be where the other places come. So therefore, our range of values for k is going to be, so I'm going to do that in purple, so I get the answer, all written out the same. K must be greater than minus root 12. So given it in third form, can we simplify that? I suppose we could a little bit. So you've got k is less than, this is the same as 4 times 3. 4 square rooted is 2. So you get 2 lots of root 3. Similarly here, you're going to get minus 2 lots of the root 3 for your final answer. So just remember, if k squared, and there's an easy way of solving these and working them out. If you've got this k squared is less than 12, so k is less than root 12, you always got an inside version here. If you can have it greater than 12, then you're going to be outside, so that greater than, then you have an or situation. You're either going to be here or here for the inequality. But in this case, we're solving this inequality, we're between the two values. We're less than the 12, and we're going to be bigger than the minus root 12.